Okay, this is project test 3, video number 4 for problems 31 to 40. Each value in a sample has been transformed by multiplying 3 and then adding 10. The original sample had a variance of 4. What is the variance of the transformed sample? So basically we have this. We have 3x plus 10. So we multiplied everything by 3 and then we added 10. So we're going to talk about the mean, standard deviation, and then the variance. All right, because all of these they're going to have different effects. First off, with the mean, I could just plug it into this, and if let's say they've given us a mean of, I don't know, 7. Then if the mean had originally been 7, we could go 3 times 7 plus 10, 21. We say the mean is now 31. The transform mean would be 31. That'd be easy. If it were the standard deviation, and we can do the standard deviation because variance, they tell us the variance is 4. So the square root of the variance, the square root of 4 is 2. So we actually know the standard deviation. So I can plug the standard deviation into there, and I go 3 times 2 plus 10. Well, we don't get to add constants. We can multiply. So this becomes 6. So the standard deviation is 6. Variance follows a different rule. It's squared. So essentially, I'm going to go, okay, 3 times 4 plus 10. Once again, we cannot add the constant. But we can't just multiply. We have to square it because the variance is squared. So we have to, the thing that we're multiplying by has to be squared. So 9 times 4 equals 36, and our answer should be 36. Now that makes sense, because if this is my standard deviation, if I just square it, I have a variance, and 6 squared is also 36. So be careful. You can multiply anything by a constant. You can only add constants to measures of center. To measures of spread, you can multiply them by a constant. Measures of center, you can multiply a constant. But with variance, you have to multiply it by the constant squared. So in this case, 3 squared is 9. 9 times 4 gives us the 36. All right, number 32. A controversial issue in the sport of professional soccer is the use of instant replay for making difficult goal line decisions. Each person in a representative sample of 102 players, fans, coaches, and officials were asked his or her opinion about the use of instant replay for goal line decisions. The data are summarized in the two-way frequency table below. Okay, so in testing to see whether opinion with respect to use of instant ray is independent. Okay, so we have multiple categories and independence. This tells me I'm looking for a chi-squared test of independence. All right, so I'm doing a chi-squared test of independence. And the chi-squared statistic of 27.99 was calculated with a p-value less than 0.0001. Which of the following statements are correct? First off, it talks about degrees of freedom. Well, degrees of freedom are going to be rows minus 1 times columns minus 1, C minus 1. So we have 1, 2, 3, 4, 4 minus 1 times 2 minus 1. So this is going to be 3 times 1. So we have 3 degrees of freedom. So no, this is incorrect. Okay. The chi-squared test should not have been used because 2 of the counts in the table are less than 5. They're trying to trick you here. We do have to have, this is an issue, less than 5, but it's not the counts, it's the expected values. So we're going to go ahead, and even though we don't have to do it, we're going to do this, check this real quickly and see if the expected values are less than 10. So, I mean, less than 5. All right, so I'm going to go second matrix, arrow over to the word edit. And I happen to have a 4x2 matrix, 1, 2, 3, 4, 4, enter, 2, enter. And then I entered the data. All right, so I already have all that entered. Second quit, stats, test. And we're running a chi-squared test. It's not the GOF, it's not the goodness of fit, it's just a chi-squared test. My observed, I just input. My expected is B, and you're like, I haven't done that yet. That's okay, the calculator will get that for us. When we go ahead and calculate, and sure enough, we get their values, the 27.99 and the p-value that's very, very small. Okay, we have ours with 5 zeros in front. And we also show our degrees of freedom. Now, if I go to back to second matrix, arrow over to edit, drop down, I can see that every single one of my expected values is greater than 5. 5.6, but still greater than 5. So all the expected values are greater than 5, so I don't have to worry about it. Please be careful. Counts, we don't care about the size of the counts, we care about the expected values. The null hypothesis states that there is an association, in other words, that there is a relationship between the category and opinion about the use of instant replay, and the smaller p-value suggests that the null should be rejected. I like this. Okay. If there's an association, they are not independent. So basically, HO, there is no association. HA, there is an association. All right. So the null hypothesis is there an association? Is like, oops. No, HO is there is no association. All right. The small p-value suggests that there is an evidence of an association. Well, HO, we have a small p-value. We're rejecting no association and in favor of there is an association because the p-value is less than alpha. All right. Okay. This was not even tested. Our test was there is no association or they are independent versus there is an association. They are not independent. I normally phrase it this way. HO, they are independent. HA, they are not independent. So no association means they're independent. There is an association means they're not independent. So please remember, you're going to have to know both of those. So please be careful with that. So once again, we had a small p-value, so we're rejecting HO in favor of there is an association or that they are not independent. 33. A large clinical trial was designed to determine whether a certain vitamin improved the general health of adults. The investigators first identified 85 variables that measures various aspects of general health. Because each adult in the clinical trial was to serve as his or her own control, the 85 variables were measured for both the adult before taking the vitamin and after taking it for 3 months. The investigators then performed 85 matched pairs, one for each variable. They found statistic significance at the 0.05 level in 2 of the variables, both in the direction of improved health. Which of the following should the investigators conclude? Well, first off, what do we have going on here? We are basically saying that we have 85 variables. Well, we know that at an alpha level of 5%, we're wrong 5% of the times. So 0.05 times 85. So that means that just by random chance alone, I would expect 4 variables to be significant. All right. So I would expect 4 variables by random chance out of 85 to be significant. There is evidence the vitamin improves health of adults because 2 of the 85 were statistically significant. Maybe. I don't really like that because we'd expect 4 or more. So 2 does not seem that significant. We'd expect that to happen. There's evidence that the vitamin improves the health of adults because the clinical trial investigators typically underestimate. That's just making stuff up. There's insufficient evidence. There's insufficient evidence that the vitamin improves health of adults because at the 0.05 significance level, one could easily get statistically significant results in 2 out of 85. Yeah, just by chance variability. We said chance variability, we expected 4.25 or 4. So this sounds like this is my best answer. All right, by chance alone, we expect to happen 4 times. All right, number 34. A sample of 942 homeowners are classified in the two-way frequency table below by the number of credit cards they have and the number of years they've owned their current homes. Of the homeowners in the table who have 4 or more credit cards, so we're looking for the 4 or more, so out of this group, so from this group, what proportion have owned their home for at least 1 year? So at least 1 year are those 2. So remember, when we're doing something, it's intersection over given. So the out of is my given. So out of the 212, what's the probability of this intersection? The 58 plus the 20, which is 78 over 212. Letter A. All right. 35. Administrators at a state university computed the mean GPA grade point for juniors and seniors majoring in either physics or chemistry. The results are displayed in the table below. When juniors and seniors are grouped together, could physics majors have a higher mean GPA than chemistry majors? Well, we're looking at this one and go, you know what? Juniors physics majors are lower than junior chemistry majors. Senior physics majors have a lower GPA than senior chemistry majors. But overall, is it possible that physics could be higher? And the answer is yes. And this is due to Simpson's paradox. And what that drives that is how many are in each group. So let's just pretend, let's say that we have 10 juniors who are physics majors and 90 who are chemistry majors. And let's just say we have 90 seniors and 10 senior chem majors. Now, I just made it 100 just to make them the same size. So let's figure out what the GPA for the chemistry majors are. Well, on average, 10 times 2.8 plus 3.2 times 90. And I divide it by 100, and I end up getting a GPA of 3.16. So that's their average GPA. Here, it was 3 times 90 plus 3.6 times 10. And I divide that by 100, and I find out that the average GPA is 3.06. Clearly, physics is greater than chemistry. But why did it happen? It happened because of the disproportionate numbers in each group, and this is known as Simpson's paradox. All right, so yes, it could happen, but whether it does happen depends on the number in each variable. All right, yes, it could happen, but it depends on the numbers. All right, so number 36. A department store manager wants to know if a greater proportion of customers on the store's mailing list would redeem a coupon of $5 off the, and by the way, greater proportion. Probably need to come back to that word. Redeem a coupon $5 off the mailing of an item for 10% off the price of an item. So the manager mails a $5 off coupon to a random sample of 500 customers and mails a 10% coupon to an independent sample of 500. The number of coupons of each type that were redeemed was recorded. Assuming the conditions for inference are met, what test procedure should be used? Well, first off, we're working with proportions. So that gets rid of anything that has to do with means. Now, how many samples did we have? Oh, we have 2 samples because we have one sample that got the $5 coupon and a second sample that got the 10% coupon. So our answer to 36 is going to be E because we had 2 separate groups. And the key thing here was narrow it down with the proportions and then notice that we have 2 samples. 37, a one-sided hypothesis test is to be performed with a significant level of 0.05. Suppose that the null hypothesis is false. If the significance level is 0.01 were to be used instead of the 0.05, which of the following would be true? All right, and when I read these, I'm just going to tell you real quickly, we're looking at power and type 2 error. Well, remember, there's a relationship. Power equals 1 minus beta, which is type 2 error. So, all right. So basically, as power goes up, type 2 goes down, and vice versa. All right. As power goes down, type 2 goes up. So what is happening in this situation? Well, we're changing our significance level. So as alpha goes down, and alpha is going down, we went from 0.05 to 0.01. As alpha goes down, beta, or type 2, goes up. So we know type 2 is going up. So neither the probability of type 2 or power changes. No, we know type 2 is going up. Type 2 error and power would decrease. No, both probability of type 2 and power of the test would increase. Remember, they move in opposite directions. So that's false. The probability of a type 2 error would decrease. No, we said as alpha goes down, and alpha went from 0.05 and it went down to 0.01. So if alpha goes down, beta goes up. So that's not true. The probability of a type 2 error would increase. Yes. And as type 2 increases, power moves the opposite direction. All right. So as type 2 increases, power moves the opposite direction. So if power goes up, type 2 goes down. Type 2 goes down, power goes up. Also, as power goes down, type 2 goes up. Okay. All right. And we can also put this in front of this as well. As alpha goes down, power goes down, type 2 goes up. As alpha goes up, power goes up, and type 2 goes up. All right, so you have these basic 2 groups. You need to learn those, please. Which of the following distinguishes an observational study for a randomized experiment? Observational study, we survey people doing what they're already doing. In other words, they've chosen their treatment. In a randomized experiment, we impose treatments on them or we randomly assign treatments to them. All right. So in an observational study, treatments are not randomly assigned, whereas in a randomized experiment, treatments are randomly assigned. And it is due to that random assignment that we can show causation with an experiment, but not with an assignment. Both can be, they may or may, an observational study can be statistically significant. It can be statistically significant, but it cannot show causation. A randomized experiment can be statistically significant and show causation. Of course, if we get if we get a large p-value, then neither would be statistically significant. 39. Frank, who is blessed and lives in Texas, and his sister Lily, who lives in Japan, correspond regularly. From what he can tell from the postmarks on both his and her sister's letters, it appears that it takes longer for Lily's mail from Japan to reach him in Texas than it does from his letters from Texas to reach her in Japan. When Frank called his post office to ask if there was a reason for this, the postmaster told him the delivery time of letters in both directions should be the same. Frank and his sister decided to collect data to see, of course they did, to see if the letters from Japan to Texas take longer to be delivered than the letters from Texas to Japan. They recorded the delivery time in days. After convincing themselves that the assumptions were reasonable, they performed a 2-sample t-test and obtained the following computer output. All right, so they have the a computer output, and it says using a significance level of 0.05, which of the following statements best describes the conclusion that can be drawn from this data? Well, when I look at this, I have a couple of things I can look at, but they give me a p-value of 0.058. That p-value is greater than alpha. So consequently, because it's greater than alpha, I'm going to fail to reject. Now, my null should be HO. There is no difference. And my alternative is Japan to Texas is greater than Texas to Japan. All right. So there's HO, or letter A, there's convincing evidence that there's no difference. No, we never say that. We never prove the null. There's convincing evidence that there is a difference. No, we're not saying that. There is convincing evidence that the mean delivery time from Japan to Texas is greater. No, there's not, because we failed to reject. There is not convincing evidence that the mean delivery time from Japan to Texas is greater than the mean delivery time. Yeah, we can say that. There's not convincing evidence. It's not significant. And the t-test cannot be used for the sample sizes this small. The fact of the matter is they can be if it's normal. And they convinced themselves somehow that the distribution was normal. They told us that all conditions were met, so we don't have to worry about it. Number 40, in a national study on transportation patterns, 1,000 randomly selected adults will be asked the question, how many trips per week do you make to the grocery store? The sample mean will be computed. Let mu denote the population mean response to the question. If everyone in the population is to be asked the question, is the sample mean X bar unbiased for estimating mu? Here's a term that I don't particularly care for, unbiased. We only have to worry about 2 unbiased estimators. So here you go. So make sure you know this. X bar is unbiased for mu. All right. In other words, unbiased estimator is if we use the calculation, will we get the population? And if we take And basically, if everyone is asked, yes, our sample would be unbiased from you. The other one would be p hat is unbiased for the population mean. Those are our unbiased estimators. If we have everything calculated in, if we take everybody, these will be unbiased. These are our only two unbiased estimators. Everything else is biased. Standard deviations, biased. Every other medians are biased. The only ones that are not biased are these two values. So why? It's because the sample mean of is equal to the population mean. If they changed it, the sample proportion is equal to the population proportion. So 40 is A because the sample mean is equal to the population mean, therefore it's unbiased. The sample proportion is unbiased for the population proportion because it equals the population proportion, right? Everything else is our distraction. These two are our only unbiased estimators.